Hey everyone, it's Mrs. Brimlow, and today we're going to talk about perfect squares and square roots. So, if you have a copy of these notes, you should be following along and filling those in as we go. If you don't have a copy of the notes, you're just going to watch the video and get a copy later. Okay. So once again, today we're talking about perfect squares and square roots. So we have run into these in our work, and so far we've used calculators, but we're really going to dive deeper and understand where they come from, what they are, and how we can evaluate them. So in the title, you literally hear a square, and when you hear the word perfect, it's exact. Okay. So we want exact squares. So what do we know about squares? We know that all sides are same length. Okay. So in a square, all four sides are the same length. That's what makes it perfect. Okay. So when we have a perfect square, the definition is when a base number has a power of 2, the result is a perfect square. So they give us 12 squared. So 12 squared equals 144. Okay. So we would call 12 our base or our square root, which we're going to see on the back. 2 is our power or exponent. And the product of 12 squared, because that just means to do 12 times 12, is 144, which is what we call our perfect square. And that's just 12 times 12. Okay. So when we have a power of 2, we multiply the base by itself. So that would tell me to do 12 times 12, which is 144. So when I do that, the product or solution is called your perfect square. Okay? And that's because if you had 144 little squares, you could form a perfect square where each side length is 12. Okay? Which we're going to talk a little bit more on the back. So let's go ahead and flip over. So that brings us to square roots. So square roots and perfect squares, these are called inverse operations. So when you think of an inverse operation, you want to think about something like addition and subtraction, multiplication and division. They undo each other. They're inverse. Okay. So a square root is to squaring a number or perfect squares as multiplication is to division or addition is to subtraction. Okay. So when you are taking a square root, you're going to see this symbol over a number. Okay. They're giving us a visual so we can actually see what they're talking about, where this comes from. We call this symbol a radical. It almost looks like a division sign, but with a little tail on the end. Okay. So what is the area of this square? So this square is made up of 4 units. Okay, that's the total area. And because it's a square, all those side lengths are the same. So each side length is 2 units. Okay. Therefore, the square root of 4 is 2 because 2 squared or 2 times itself gives me an area of 4. Okay. So your square root is describing, the number of units it takes to form the side length of a perfect square. So let's take a look at the next one. So this square has a total area, if I count all these little squares, of 16. One side length, any of them I could choose from, is 4 units. It's a 4 by 4 square, giving me the area of 16. Therefore, the square root of 16 is 4, because 4 to the power of 2, or 4 squared, is 16. Okay? So there is either going to be a perfect square root list attached or one provided in class for you to help you start learning, becoming familiar, and even memorizing these perfect squares. Okay, which you will be allowed to use on assessments or graded work as a resource. Okay, so go ahead and check Canvas to see what your activity is, or check in with the teacher to see what's been left. If you have any questions, let me know, and I will chat with you soon.